feeling I used to have me. Oh, you just don't do the sweet things for me, baby. Oh, baby, 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 the way that you used to do. That's why I lose the feeling that I'm
Hi, good afternoon, everybody. Welcome to our Routing Working Group meeting. Please take your seats, and we'll start. It's second.
There you go. Clicker.
Does it? Okay. Good afternoon. My name is Jen, and I'm going to remind you about working group draft about enterprise multi-homing. And I really hope it's the last time I'm talking about this, because we've been talking about this for a while. So the problem is how enterprises could use provider assigned address space and be multi-homed and connect to different providers. History. So first, we presented this draft in Berlin in IETF 96, and you can find the link of the 40 minutes presentation I think I made. And I can remember quite interesting and quite long discussion on Berlin. Then the draft had been updated, and it was adopted a year ago. It hasn't been many changes in the draft since then, and the last few times I sent updated drafts to the list, I could not recall real feedback. So the last update was done before Singapore because, we found some issues with logic of generating source prefix code forwarding tables, which potentially could have caused loops. So the logic was updated, and now the draft agrees with what destination source routing says. So because this draft has been around for a while, I believe, but I may be biased here, that it's good enough. So I have a question to the working group, any other comments, suggestions, how can we improve it? And if there is no comments or suggestions, maybe we can do the last call. And obviously, because half of the draft is actually quite a lot overlap with V6 ops space, I assume we need a V6 ops to review it if we go for the last call.
So since Chris is co-author, I'll be running the document. From my opinion, it's ready for working group last call. And unless there are objections, I think I would start it after IETF. So if you have any objection, questions, please let us know. Thank you.
Next up is Hayu Song, talking about a network telemetry framework.
Good afternoon, everyone. Today I'm going to talk about our new initiative on setting up a framework for network telemetry. Now, network telemetry has become a mainstream term in network community, but perhaps many people still have a different understanding on what scope is it and how to map the existing work into it. From its Greek root, telemetry means remote measurement, right? So in this sense, we believe the main purpose of telemetry is to gain network visibility. So any technology that collect data from network and analyze on it, do some measurement on it, is qualified as telemetry. In this sense, conventional OEM techniques covered in IETF can be considered telemetry. But as network is evolving, we think we need new telemetry, which will also have some new characteristics associated with it. The key motivation of this work is that we are seeing the network is evolving toward intent-driven and automatic, with the aim to reduce human labor, to improve network agility and performance, and also optimize the network resource efficiency. In this new network architecture, that network visibility is very key to it. Therefore, we should promote telemetry as a first-class citizen in network technologies and protocols. And also, we think the telemetry work should be better unified, consolidated, and integrated to support the future network architecture. Currently, the OEM tools we have, such as SNMP, is inefficient and insufficient to support the future intent-driven network because it's based on the low-frequency polling and the command line interface. It's also lack of the coverage, timeliness, and accuracy that is required by the intent-driven network. Also, there are many existing works in IETF, but they are mostly fragmented and scattered through different working groups. And we have many different piecemeal vertical solutions, which are very hard to compose into a cohesive one to support the one single intent-driven engine. There are also some repetitive and redundant work. So we need to collaborate and consolidate the work together to at least we understand what's our... Okay, so question.
I apologize for interruption, but I think that your characterization of existing OEM is very subjective. Because, again, for example, if SNMP is, and I agree, SNMP is not the right vehicle to export OEM metrics or measurement results, then we have Yang models, and Yang models for being developed and almost complete for BFD, and Yang models being complete for performance measurement mechanism defined at IETF and other organizations.
Yeah.
If you're looking at methods used yesterday,
I acknowledge those works. I qualify that those are new telemetry technologies, which will be covered.
They're new.
I don't say they are outdated or they are not useful, anything about that. This work is just to try to summarize what's available and map it into a clear framework to help us understand, and then we can fill the gap.
Maybe then I would suggest not to use characterization like inefficient, insufficient, scattered, and unorganized.
Greg, let's wait till end of the presentation. Okay.
Okay. So yeah, so that's why we want to set up a framework to normalize the concepts, terms, and which can help the technology and the standard development. So basically, the new telemetry requires to continuously monitor the network and also dynamically change the monitor point and refocus the monitor point. We need to correlate data from multiple data sources, and we need to support in-band measurement in addition to the passive and active measurement functions we have. And also, we cannot afford to collect all the raw data. We need to take advantage of the programmability of the network data plane devices to support the customized and the pre-processed data.
Excuse me, I have to interrupt you. Are you? No.
Can we hear him speak?
No, because it's inaccurate. It is wrong.
Live. Let the speaker speak, please.
Are you implying that active measurements are not in band?
What's the question?
No, you are saying that in band measurements are in addition to active measurements.
I'm not saying they are not in I say we need all of this. And there are some existing work has already addressed this. I acknowledge that. Mm-hmm. And okay, finally, we need to make sure the telemetry won't interfere with the data plane device performance. There are many use cases. I won't restate them, but they are mainly doing the intent reinforcement, also the fault analysis and prediction and the performance optimization. And finally, for the network security. Some new characteristics, including the push-based data collection instead of a pull-based. And streaming data with efficient encoding is model-based for better software automation. Also, in-band data collection is new emerging technologies. And also we need to support custom and on-demand data. And the tools, also the protocols technology need to be better integrate with big data analytics and machine learning tools. Therefore, we want to partition the telemetry into 3 planes, namely the data plane telemetry, management plane telemetry, and the control plane telemetry. And in each plane, we further partition the telemetry into 5 components, starting from the data source to the data subscription and data generation, data export, and the data analysis. Based on this partition, we form this 2-dimensional matrix, and we can map the existing work in IETF into this map. We can see some are already standards, but some are just recent proposals. Based on this figure, we can see what's missing and how we can map. I'm sure I miss a lot for existing work here, so they will be eventually filled into this figure, and also it helps the system designers to understand how they can integrate a complete solution. So to recap, so our main purpose is to promote the significance of telemetry work in IETF. And we need to keep, when we design the new technologies, we need to keep in mind the big picture. In the future, we need a more automatic network architecture, which requires we have a better interface with underlying tools. Also, we want to make sure that IETF becomes a leading standard organization in this area. So we try to formalize all the telemetry-related terms in IETF and do the proper technology classifications. So therefore, we can consolidate the existing work and get the future work. Of course, it's a very early step we have, and we need your help to finish this work. So thank you very much. Question?
Mahesh Jetanandani, Sorient. So I definitely support the effort that you're trying to make to try to consolidate the work. I would highly encourage, and this is with my chair hat on, for the NetConf working group, where a lot of the work is happening as far as telemetry and Yang push is concerned, is for you to take your presentation and bring it to the NetConf working group, because you will find a lot more people there who can probably give you more guidance in terms of the effort that's already going on there.
Yeah, thank you.
Given multi-area focus of the framework, this is the intention. So routing is not the only area where it's been presented and worked on.
Agreed. But I think in general, since from a technology perspective, it would be at least on an informational basis, inform the NetConf working group, even if the work is happening other places.
Rick Taylor, +1. I was actually going to say exactly what Mahesh just said. I think this is important work, but it needs to span all the areas. We're not very good in the IETF at collating big topics that span many areas and somebody owning it and making the documents come together. So it is always a challenge. And I really hope we can come together and say these big spanning visionary areas of work need to happen. I know some of the language is contentious, but that's what you thought through, So big +1.
Thank you.
Greg Mirsky, ZT. I really wonder why we started using telemetry rather than OEM, because OEM can exist on different layers. It can be data plane, control management plane, but if we prefer refer to this telemetry, fine. In the document, I would encourage not to use any marketing or any drawn conclusion comparing different technologies and making conclusions that one technology is better than another. And I would suggest to look into their more requirement side rather than evaluating technologies what we have today, because I will find, you probably will find that requirements are more needed, especially to fill the gap, requirements and gap analysis, rather than saying that this is better than that.
Yeah, but in terms of the OEM and telemetry, I think my understanding is telemetry will be a more broader term to cover different aspects of the entire data collection, the consuming loop. So, but maybe if we use an OEM, and maybe that's have some narrower meaning. That's why I think we need to at least to normalize the language we are using. So when we talk about the term, we both understand what we are talking about.
Right.
This is Linda Dunbar from Huawei. I think this is a good work, and I think IETF, as other gentlemen said earlier, we need to think from bigger picture. And the lots of network being deployed today is not just one segment of VPN, one segment of this. It can be many, many elements involved. And like ONOG, the enterprise is talking about everything beyond my Java is network problem. And we have issues and some like, for example, the traffic comes in are from CDN. So the source address are different. And then going through net, by the time I need to monitor my network, the source address doesn't mean anything anymore. So having some kind of bigger picture view of how to look at the entire end-to-end telemetry, I think is very useful.
Hi, Jamal Hadi Salim. So in very large environments where we've deployed forces, this has become a niche for us. We're very good at this. So please consult with us when you take your next steps.
Okay.
There's a lot of mechanisms that we built into the data models, into the protocol itself, the publish, subscribe, the thresholds, how to describe events that can be subscribed to, etc.
Yes, thank you very much. That's exactly the help we need. Thank you.
Great, thank you. Linda?
Good afternoon, everybody. Oh, I'm staying here. Okay, so today I'm going to talk about some general problems we face and when enterprises are moving their workload to different places. And here we call network to cloud. Cloud here, just want to clarify this, quantify this. Cloud means my workload is running on somebody else's infrastructure, meaning that I don't have control of the physical infrastructure. And so this work is combined with Mehmet Toy from Verizon, Christian from Orange, Andy Malice, and myself. Okay, so just a little bit introduction. The introduction may be too broad, so bear with me. I'll talk to you about more narrow scoped IETF work. So the work is driven by the challenges facing by enterprise in today's world. And I've been going to ONOG for last year, and most of the enterprises today need to move the workload into the cloud simply because the availability of the location. And here, when we say cloud, it doesn't mean AWS cloud. It can be the SD-WAN endpoint, which is moving. Like basically, the reason enterprises put together SD-WAN is because they may have some locations very close to their end customers, and they need to network to interconnect them. And those endpoints, they don't stay there very long. They may stay there for a short period of time. And how do we interconnect them together? So ONOG, 5 years ago, they created this SD-WAN, so allow the enterprises to be able to interconnect together. But after many years of deployment, they find out actually SD-WAN over shorter distance works fine. You put your end devices together. You can have the IPsec tunnels and utilize some other network and be able to utilize all the resources together. But when you have endpoint cross city or cross continent, the quality of service is getting unpredicted, right? Depending on whatever network you're running over. So that they look at more and more about utilizing existing network. Like enterprise today, they may have like a VPN network, service provider network, already interconnected together, many branch offices and on-prem data center. And now they have some dynamic locations, either in third-party cloud data center or maybe the SD-WAN. They need to integrate together. Here is an example of like in ONOG, twice a year they have enterprise communities putting together their highly desired use cases, and they put a vote on which one they think is the most important to them. And only the end user, enterprise users, are allowed to work together on those use cases. And vendors being like on a different community, be able to support that requirement. So one of the highly voted use case is how do we interconnect the existing network, like which is already connected, like our on-prem data center, our partners data center, or our branch offices, interconnect with some dynamic locations, which can be in public cloud, or maybe it's SD-WAN in some remote location temporarily. So the goal for that is because they want to push the workload closest to their customers. Like some of the enterprises today are already moving 40% of their workload into the cloud. But those cloud actually is temporary, only used for special purpose. Most of the key data storage, key applications are still stored on-prem. Like, for example, identity management, the key essential data, they're still managed on-site. So this is based on this use case. Here is talking about, when we talk about cloud services, there are actually, you can see distinct two type of services. On the top is an example of AWS service. Is a cloud operator, they offer service directly to end user, to consumers, to enterprises. You can create different kind of services. You can create network service, you can create database service, and another type of service is managed service. The managed service meaning you have third party, which can be network operator, or could be Amazon's partner. They manage the resources for the enterprise. They can also utilize some other cloud operators. So for this MEF, I just gave people an introduction, started this work. For example, here on the left side is about how do we integrate our MPLS network with the last mile being the SD-WAN. Okay, and second project in MEF is the cloud service architecture, meaning as a service provider, managing, getting the resource from different cloud data centers and being able to offer that to the end users, utilizing existing network. So it's a pretty big project, but the key takeaway from the MEF and from the previous use case is really about the MPLS network do stay, and they have large deployment, they have proven to be scale and have quality, but this kind of network do need to be augmented by some dynamic part of it, like SD-WAN, and especially in the NFV environment. And then there's a need to be able to connect dynamically the tunnel points. So let's go back to like enterprise using last mile SD-WAN to connect to the dynamic point, which can be in the public cloud or partner cloud. So using the SD-WAN approach, you end up having many SD-WAN tunnels. And those tunnels, when you have just one branch, need to reach the cloud. it works fine. When you have shorter distance, it works fine. But when you have multiple locations, you have your on-prem data center, you have partner data center, you have branch office, all need to reach to those dynamic locations. The number of tunnels you have to manage is getting really cumbersome. It doesn't scale. So a better scalable solution will be integrating existing network enterprise are currently using. They are currently already interconnected by the provider VPN, which can be leased line, which can be L2 VPN or L3 VPN. And using those network, leverage this network to connect to the dynamic location, which is more scalable. Or they can have this kind of SD-WAN aggregate kind of thing, be able to aggregate a bunch of locally SD-WAN tunnels and using their either lease line or provider network to connect to the cloud. This example just shows another variant of the traditional SD-WAN. The traditional SD-WAN is more about 2 endpoints and being able to utilize all the resources available, aggregate them together. But when you have workload in dynamic locations, in third-party data centers, and your workload can be shifted from one location to another location. And also, you can connect to your workload through multiple ways. Like using AWS as an example, they allow you to connect to the workloads through internet gateway, allow you to connect to the workloads through the virtual gateway, which is IPsec tunnel terminated at the gateway. And they also allow you to connect through the direct connect. So you can connect them multiple ways. So that means the SD-WAN becomes not symmetric anymore as the traditional sense of SD-WAN. Oh, okay, quickly. I'll just go quickly. Basically, in many, here I'm just talking about a little bit proprietary implementation on SD-WAN. Many vendors, several vendors, I should say, extend existing NHRP for creating dynamic tunnels among the SD-WAN switches. NHRP originally was used for IP address, ATM address resolution. And when used in the SD-WAN environment, is try to resolve your VPN address, your public IP address, and your IPsec key. So that's the extension by different vendors have different ways to extending the NHRP. And for the cloud interconnection or reaching the dynamic location, then the resolution is added with the third dimension. Not only you need go through the VPN address to your public IP address, to your IPsec key, and you also need your private address within the third-party data center. So this resolution becomes another dimension. And another key part is when you have different locations, you have different applications, the remote head-end node, actually many of them are built with application aware. So they know what kind of application they are. For example, for the voice IP application, you can reside in different locations. And depending on different scenario, they may want the traffic to be routed certain way. But the first segment maybe is SD-WAN, is the internet. You cannot control how the traffic are routed. But once you get to the provider domain, and we can have segment routing, or we can have some other method to traffic engineer the path, and using some kind of method to distribute the key or label to the head end will alleviate lots of problems in the provider domain and be able to allow the traffic go through certain path. I already talked to some people in the segment routing group, see that being the use case for the SD-WAN in segment routing. Okay, here's my last slide. Okay, so why we do bring to IETF, right? A couple of reasons. One reason just to bring you some of the discussion being done at the ONOC and some of the trend and what enterprise want, and breaking down to detailed problem what IETF can solve is mainly about how do we do the resolution protocols properly. Maybe we should have a standard resolution protocol instead of each vendor enhance their own existing old NHRP protocol, which was done many years ago. I think Andy was the chair for that 2 decades ago. And also allow those mini data centers located in different places to route with each other. I agree that EVPN has been there to be able to route all those mini data centers, but here is the case where you have many of them, and many of them can be floating, and how do we route them with each other? And to determine there's any interest here. So I'm standing here just mainly to kind of advocate this kind of issues and requirement and gaps, and whoever are interested, please talk to us. Thank you.
Stuart. And next up is Stuart Bryant talking about enhanced VPN. Well, if, yep. Nope.
Thank you. I'll get one of these, don't I? I'll move that forward a little bit so I can still stand in the box. And all right, so I want to give you an update on the work we've done on enhanced VPNs, known as VPN Plus. So the purpose of this discussion is to explain that version 2 that we've just released was an editing pass aimed at producing a much more coherent view of the problem and the solution. So we've tidied up the English, we've tidied up the structure of the document, and we think it is much easier to read and understand what we're proposing. We're now actively also working with 2 service providers, and we've been taking some of their input as well, or taking any of their input. So the purpose of this slot is to discuss some of the issues that were raised at the last IETF that require some discussion amongst the working group. So remind you what the architecture of the solution is. The underpin of the solution is an enhanced data plane. So something that's supporting FlexE or TSN or deterministic networking or a sophisticated queue priority architecture. What we want to do is to create VPNs that map onto a specific and dedicated set of resources that are set aside to support that specific VPN. So what we are trying to do is to do a tighter underlay-overlay integration than is classically done with a VPN. On top of that, we will need a control and management system that's sufficiently flexible and scalable, and in particular, capable of doing individual VPN management. But we are not focusing on that in this document. What we want to do is to get the data plane such that it can serve the needs of these new services. So as with all things, there's a spectrum of requirements. In particular, one of the key ones we're dealing with is isolation of the traffic that's running on the different VPNs. So we want to provide better isolation, or our customers want us to provide better isolation that allows new applications to be deployed rather in a packet network rather than needing a dedicated network. So if you look on the left, we have ordinary statistical multiplexing. If you look on the right, we have the absolute isolation that you would get from a dedicated network, for example, a FlexE network. Or a completely dedicated network. We're looking for a pragmatic solution somewhere in the middle. And I kind of like to think of this in terms of what we did with pseudo-wires. With pseudo-wires, we took the view that if you wanted a real absolute copy of the type of network you wanted, then you bought a real one. But actually, for most applications, most of the time, you could be not quite as perfect as a real dedicated network, but nonetheless solve the problem that the customer had in an economic way. So we're trying to do the same thing with isolation, which we're trying to design a system that is good enough for most users, but doesn't have the expense of a dedicated network. Again, in terms of performance, guaranteed latency and enhanced delivery, they're the the scope of deterministic networking. But deterministic networking has not got a good story yet in terms of integration with VPNs. So that's one of the things we need to do. Assured bandwidth is commonly, as provoked Lou, assured bandwidth is something that is commonly provided with VPNs, but we think there's some scalability concerns. So we're trying to get the best of all worlds. And Lou, go ahead.
Oh, Lou Berger, I completely agree with your statement. The only question is where do you think it should be done?
Well, I've got a comment about this. We don't care where it's done. We've got a comment about why we think at least a framework should be done here. Let me get to that slide, and then we can have the discussion.
Okay.
But
thanks.
I don't mind where it happens.
Okay.
So the next thing that we talk about is segment routing with resource allocation and identification. So SID allocation based on resource requirements is a key differentiator for this work. So we want to tie the SIDs to resources, detailed resources. So for example, specific queues and virtual links. So going forward, we plan to document the resource allocation and identification based on service requirements. We've got a draft in spring that describes the enhancements we think that need to happen to SR. It's really unfortunate that that discussion clashes with deterministic networking discussion, because I think both communities need to be thinking about this. We're also anticipating doing some routing protocol work, probably somewhere in LSR. Scaling. So with RSPTE and MPLS-TP, we would need to set up a complete end-to-end path for each service that requires unique resources. That is to say, a label per path on each node in order to bind specific resources on a particular node to the service. Now, that's not needed with SR, but currently SR has no resource allocation sort of service, and we need that to be in place. So what we're trying to do with VPN Plus is to add the resource reservation to SR in the context of this type of goal. So this allows us to mix resource reservation with resource aggregation along a service. That is to say, at some point along the service, you may need a specific resource. And another point along the service, you may be quite happy with taking the general pool of resources because a relatively crude aggregation is good enough. So what we're trying to do, Greg?
Okay, so with this statement, adding resource reservation to the segment routing, so does that changes the paradigm of segment routing, creating the state specific to the segment routing tunnel that is resource context?
Yes. All right. And indeed, if you look at where this ends up, if we need to have resource at every hop for a particular service, it really becomes, folds back to a single end-to-end LSP with all the services added. So, but we think that actually you won't need to do this because in some cases you will require a dedicated resource. Great. You know, we have to do this. In other cases, we think that it can be shared at some level of granularity, and in other cases, it will depend on where you are along the path, whether you're able to use common resources or dedicated resources. So, for example, if you have a very lightly loaded high-speed sector, it may be perfectly adequate to just take your chances with the pool, whereas in other places you may need specific dedicated contention sort of based help. So where does the framework belong? Remember, at the moment, we're just writing a framework to describe this problem so we can all get our heads around it. So at the end of the day, the chairs and the ADs own the decision. But here's how we analyzed it. We don't think it belongs in Spring because the design is broader than segment routing. All right, it includes other potential types of method of delivering the service. We don't think it belongs in DetNet because it's not simply about determinism. And we don't think it belongs in TEAS, at least currently, because the current TEAS charter specifically says MPLS, and this is not exclusive to MPLS. So, but we do need an incubation group to start this work in, which is why we have brought it here, because this is an incubation working group. So we're not quite ready to ask for this to be given a formal home. We need to do another pass on the document, but we think we're close to asking for this work to be given a formal home in the IETF, and then to ask for working group adoption so that we can work on it collectively. And I don't care which of your working groups or this one it goes in.
Okay. I didn't know if you were ready for
Yeah,
comments.
yeah.
Lou Berger, can you go back one slide?
Back one.
So I think it would be great to find this a home. I think it's really good work. I think it's important stuff. I actually agree from a technical side with everything you've said.
Yep.
I think DetNet needs the function,
Yes.
and needs to worry about defining how it does the encapsulation. And I completely agree with you that there's a larger discussion
Yes.
here, and it's overarching, and I think it's great to have. The only thing I don't agree with is that it doesn't belong in T's. I think while there's clearly a debate going on right now about the intent of T's, that probably should be clarified. When it was described to me at the time, and the ADs who described it are both in the room, so they're welcome to disagree with me. It was that this was supposed to be the central point for traffic engineering architecture in the IETF, so that we do things that are consistent and reusable. And that's why the main purpose of the group. And it's important to find this protocol a home, and we know that it's diminishing in terms of importance, so we'll put it here because we're not going to have much work in that area. So I think it's squarely belongs with my understanding of what the charter was supposed to say. Well, we have to fix it.
We need a discussion about this, because when I read the charter, the very first thing it said was MPLS. And we need to be able to deal with other.
Yeah, so I think there's some cleanup there, but I think everything you're talking about the resource control piece fits in very nicely with the work we're already doing there.
So we just want to work where the experts are. And I think if the chairs and the ADs can suggest which one we go to, we will go there.
To add to Law's comment, so in routing space, traffic engineer has very particular, or resource reservation has very particular connotation. What she meant is really soft resource reservation. So you don't do on-pass, the reservation is done off-pass on the controller level, right? So which brings TS significantly back.
TS is, I refer to it as the big tent. You want to do reservation through distributed signaling? Great. You want to do it through central control? Great. You want to do it even maybe through other mechanisms, which is implicit? That's great. Certainly the aggregation piece is a fundamental notion of hierarchy that we've long worked on, and I think you got the description exactly right. But sometimes you need to do per flow state, whether that's done through an orchestration mechanism, a management plane, or a distributed control plane. Sure. That's all part of the Big Ten.
My point was there's close cooperation between two working groups if we decide to work separately.
So, I mean, if I have to go and present it in both from now on, then I'm absolutely fine with that. I just need a home.
Greg Mirsky, everything that is great, and that's long time due. I probably would have changed a little bit this statement about reservation in a segment routing domain. Probably would put a question mark, saying that may need, because again, that's something that probably now at this time is too early to say that it's requirement. It might be one of the solutions. There could be other solutions.
We welcome feedback on the design.
Yeah, but at the same time, let working group chairs and ADs to figure out where, and we can start the work.
Thank you.
In concurrently.
Yeah,
we don't have to wait for them to decide.
Correct.
Hi, Rüdiger Geib, Deutsche Telekom. If you link a resource to a label, then I think you're talking about ELSPs and LLSPs. I think that was what they differentiated in the early days of MPLS, but this is not related to Spring. Thanks.
Sorry, just what's the difference between this VPN Plus and let's say a slice?
Shall I say that again?
What's the difference between this VPN Plus and a slice?
Do you understand? Slice. Oh, a slice. Yes, well, they're very, very similar. And we've kind of been skating around this because we didn't want to get involved in the net slicing debate and argument, because we think that this is a useful technology in its own right, whether or not net slicing ever happens. So we've deliberately skated around this. This could be is a perfectly fine underpin for network slicing. It's also a perfectly useful technology if net slicing never happens.
Martin Vigreux speaking as routing AD. A question for clarification. In case that work was going to result in multiple documents being produced, do you plan, or what are your intention to progress them in a single working group, or are you open to? I wasn't clear to what was your position on that.
We will need. We will probably come here with an ISIS document next time. That clearly will happen in LSR. We have already got a Spring document to explain that relationship. That would clearly belong in Spring. What we need is a home for the architecture document, which brings shows how all the pieces fit together. So my view has always been, you do the work where the expertise is. And I'm looking for the correct home for the expertise to work on the framework to start with.
Okay, thank you.
Okay, thank you. Thank you for your time.
Okay, next up is Karsten Rosenhavel, and he'll be talking about some testing results of TILFA implementations.
So I don't know who of you knows ENTC. We're an independent test lab, and we've been running multi-vendor interoperability tests of transport network innovations, i.e. IETF draft, for the last 15 years. And so this year we focused our test around segment routing, PCE, EVPNs, obviously, and we created like a mock network, wide area network, data center network peering, and services connecting all of these. And the hot staging just finished last week, so I'm happy to report some of the results here that are related, actually two drafts that are related to this working group. We had 21 vendors joining us, so there was a good group representing the industry, and a total of 75 engineers working to get this test done in 2 weeks. And the results will be published soon at a conference in Paris. So what I'm covering here is 2 drafts regarding segment routing, topology independent loop-free alternate, and microloop avoidance. And in total, we were able to test 12 vendor combinations in this environment. Of course, we set up segment routing domain. We had like a ring in topology in each of these cases. We tested both MPLS-based segment routing and SRv6 data plane. And in each of the cases, we used ISIS with SR extensions to get the routing done. So if you look at this diagram, so basically there are 4 nodes involved in a ring topology, and if we create an emulated link failure between node 1 and node 4, of course there needs to be some rerouting. In the traditional fast rerouting case, which we also tested over segment routing, it's fairly straightforward. Only one segment ID is required in both directions to guarantee a loop-free alternate. And in TILFA, because the way the protocol works, 2 SIDs need to be introduced. Node 3 and node 4 need to be inserted so that the traffic is forwarded correctly. So this is the test scenario, setups 1 and 2. And a third one was testing shared risk link groups, SRLG. So we basically set up a cross link between node 1 and node 3. Then we connected the two in an SRLG and said like link 2 shall only be used if link, what's the number, link 1 is also up and running. And then we failed link 1 so that node 1 had to decide, okay, I cannot use link 2 anymore because it's part of this shared risk link group. In that case as well, it was necessary for node 1 to insert SIDs for node 3 and 4 to prevent any loops, and link 2 was not considered. So these were the three scenarios, and that's what we asked the vendors to implement, or actually the other way around. That's what we discussed with the vendors in the last few months since we started in November to prepare all this. And not surprisingly, all vendors participating supported FRR, so that works pretty fine over segment routing. Only half of them supported the topology independent solution, and only one of the vendors supported TI-LFA with SRv6. So across all of our tests, not only in this specific case, but across all of the segment routing tests, we found that SRv6 support is very limited at this time. And it seems also maybe service providers are not asking for it so much outside Japan. So only one of the vendors also was able to test the TI-LFA with this shared risk link group. So that doesn't seem to be implemented so much yet.
Clarification. How were SRLG signaled, or were they statically configured on the device? SRLG signaling. How was it done, if at all?
I don't know. I don't know how it was configured. Are there multiple options? Okay.
Yeah. So we were also trying to get author of the draft to include SRLG specific information in the draft, and it's still being discussed.
Okay. So we're going to publish a very detailed report by April 10, and I'm going to get back to you with an answer.
If you could publish the link to the report to the list, would be great.
It's here on the next slide, on the last slide. So only one vendor supported the SRLG, and we had test equipment vendors, two of them who actually supported all of the options, but of course they couldn't function as transit nodes because they cannot forward traffic. They can receive traffic, they can send traffic, but they cannot forward it, they cannot transit it through their devices. So that limited the number of test cases a little bit, and I hope next year we'll have more combinations to be tested, and we'll have the chance especially to see more SRv6. So the report will be published at this URL shown here, and we have quite a number of other drafts covered from Spring, from the MPLS working group, from 6man, and from other working groups here as well. So, not sure. Are there any questions?
AC Lind of Cisco Systems. I was just looking, I missed a little bit of it, but it looks like for your scenario with the SRLGs, the point of local repair could just use local SRLGs. So in answer to Jeff's question, you really wouldn't need to single them for this specific scenario. Is that correct?
Hence my question.
Yeah.
Well, I think since only one vendor supported it, I guess, you know, it's of course it's my team who ran the details of this test. So I guess they actually started with the most simple scenario. So it could well be possible there was no signaling involved. Any more questions?
No. Thank you for taking the time coming here. We would love to see you more and possibly with a bit more details. I know it's policy of NTC not to disclose who supports what, but at least a bit more details what didn't work would be very useful.
We'll disclose everything in terms of, especially of the positive test results. We never disclose failed test results because what's the point? You know, people should go back to their labs and improve and not be punished. But we always disclose by name the vendors who do support things positively. But currently we're in a review process, so the timing was a little unfortunate. By 10th of April, the report will contain all the vendor names.
Thank you, and looking forward to seeing you again here.
Thank you.
So next up is Igor Lubashev, talking about an idea for ingress filtering for asymmetric routing.
Hi, my name is Igor Lubashev, Akamai. First, I would like to thank the chairs for finding the time for this talk on such a short notice. My goal here is to talk to you about some very early work that we're doing. It's flickering, nice. So I'll start with presenting you with a problem that everybody here, or most people probably are very familiar with, but it's still a problem after so many years, so I guess I have to continue with trying to encourage people to solve it. And I'll conclude by proposing a possible solution. It seems to work to me, but I'm definitely not particularly committed to any one solution. It's just something that, as long as we solve it. All right. Ingress filtering. We have here each of the routers is actually at a separate AS. We have ASX. It originates prefix P. It's probably a customer of B and C, and ABCD are all peers, although they don't all peer with each other. So X advertises P to B and C, which advertise it forward to A. A uses its decision process and somehow comes up with B is the next hop. It also talks to D, but no prefix P is exchanged there. All right, so BCP38 says that you shall run a secure network, and for that you shall do ingress filtering. And BCP84 gives some alternatives what to do for a multi-home network, which X is, and most of the complex networks are. The alternatives are configure it all manually, and that's very nice. That's one of the alternatives. It's probably very labor intensive, very error prone, will not work. Alternative B used strict RPF. And in this case, so if we're looking at A would only allow traffic from B, because A would see that B is where it would forward the reverse traffic, that interface. Obviously, it will not work. So feasible path is another alternative proposed by BCP84, which says A should look at any announcement and use any of the interfaces it has announcements for as valid interfaces for ingress for P. And that works well, very nicely. There is also loose RPF, which basically says if anybody announced P anywhere, then it's all good. That's almost not a filtering at all. So it works all very nicely because it's a very symmetric routing here. So let's look at asymmetric routing. What does it mean? X wants to receive packet only from B. It does not want any ingress from C at all. But it wants to be able to send to C and to B. The only reliable way of doing it is don't announce to C, because if you do, you may receive packets. And that's not what you want. You don't know what policy C has. And even if you try to convince C that they really should configure to allow, like to make an exception for you, C may want to do, may do it, and they may want to help you, but they probably have a whole ton of peers and trends that they will have to have the same conversation with. So basically, asymmetric routing is not a good thing for basically unicast RPF. And the main reason is we use the same signal, BGP announcement, for two separate purposes. One is, please send your traffic here. And two, allow me to originate, to basically send from here, from the same interface. And those two could be separate purposes. So what ends up happening in the internet is, well, C doesn't want to screw its customers, so maybe no ingress filtering there. A doesn't want to mess with traffic from C, so no ingress filtering here. And that means that anybody can spoof traffic from P, and our little hacker here and that's sending traffic from D is very happy. That's kind of the state of much of the internet today, and that's not good. Now, for people who thought that, well, just announce, always announce, that's a good idea, and say you could always prepend, which already has a danger that C will send to you. It's not really a solution. In this case, B and C do peer, and C is configured to actually honor shorter path. So it sees that path through B is shorter than directly from X because it has prepends. So it does not advertise to B. And that means if X does send traffic through C, B will not be able to apply feasible path RP filter. Okay. So first, I want to encourage people to look at this problem again, and it is important. We do want to run a secure internet. Solving ingress filtering for more people will, well, first reduce operator headaches. And I mean, for people who actually don't care about operator headaches, well, that's what Tylenol and Scotch are for, depending on your medicine. It will lead to wider ingress filtering deployment if it works for more people. That means a more secure internet, and now the headache is on the bad guys. There is some work happening right now in parallel in OPSEC group with enhanced URPF proposal. It's a good proposal. It does solve a number of cases. It doesn't solve all of them by far. It basically works on a very, very high level by not matching path to interfaces, but trying to guess path belonging to ASNs on customer interfaces. It doesn't really work for very large networks with lots of customers, and it doesn't really work on peer-to-peer traffic, so the problem is still there. I promised a proposal for a solution. So the proposal is creating a new ingress-only SAFI code, which would basically act as a ingress-only advertisement. It's like a normal advertisement, except it's never ever used for actually forwarding in the router. It's only used for feasible path RPF calculation. And those advertisements are transitive. And if there is a covering route, so same prefix or shorter, that is advertised to appear, a covering route could be another ingress only or a regular advertisement, then you do not need to advertise ingress only to that peer, because a regular advertisement means bidirectional. Obviously, because it's a new SAFI, only routers that do support this will get the announcement. And in terms of originating the thing, the rule is if a customer advertisement is not re-advertised to a BGP peer, any kind of BGP peer, transit peer, another customer, because of whatever reasons, like I said, no export, prefix path, link capacity, business goals, whatever you want, then only advertise ingress only to those BGP peers. And of course, if you have your own prefixes that are not advertised to a BGP peer, then advertise them as ingress only. And that's it. I would love comments. I would love see if there are people who are interested in working more on this, in this area.
Thank you. Right.
Next up is Fred Templin. He should be presenting remotely via Meet Echo. And he'll be talking about BGP-based mobile routing for the aeronautical telecommunications network.
I'm online now. Do you have me?
You look great. We can hear you.
Very good, thanks. Okay, thank you. What I'd like to talk about today is what we call a simple BGP-based mobile routing system for the aeronautical telecommunications network. Next chart, please. So some background on this. The International Civil Aviation Organization is currently building an IP-based networking system for worldwide air traffic management. And this is for civil aviation for managing all flights that happen worldwide. They want to build a service that provides IPv6 capabilities for air traffic controllers to talk to airplanes. So they're developing what's known as the Aeronautical Telecommunications Network with Internet Protocol Services. And again, this is an IPv6 based service. It will be all IPv6 from the start, no IPv4. It's under development in a standards body known as ICAO Working Group I. Working Group I is kind of like the IETF of ICAO. Again, it's IPv6 based and mobility capable. And one of the key features is what's known as multi-link, because aircraft will have multiple data links attached to them. They may have SATCOM links, a new link called LDAX, which is an L-band cellular link technology, VHF links, and others that are going to be available to the aircraft during different phases of flight. It could be that some links will be available during the continental domain cruising. Other links will be available during oceanic domain when we don't have any cellular coverage. And still other links will be available during airport runway on the ground situations. Next chart. So ICAO Mobility Subgroup Solution Discussion, they're currently looking at 3 candidate mobility solutions: Mobile IPv6, Proxy Mobile IPv6, Ground-Based Lisp, and the BGP-based overlay approach, which is the subject of this document. And we call it a simple BGP-based mobile routing system for the aeronautical telecommunications network. It's based on a BGP overlay network that's separate from the global public internet BGP routing system, but may or may not be linked to the global internet BGP routing system with filters to keep undesirable traffic off. Right now I'm having pixelization. There we go. It's based on a hub and spokes arrangement with regionally distributed stub autonomous system border routers and centrally located core autonomous system border routers. The stub autonomous system border routers advertise and withdraw airplane mobile network prefixes. And the core autonomous system border routers are in a hub autonomous system, and they forward packets between the stub autonomous system border routers. Proxies connect data link subnetworks to the overlay, and clients are aircraft that may connect to multiple subnetworks. And then we have route optimization that removes the autonomous system border routers from the path when they don't need to be in the path. Next chart. So here's what it looks like diagrammatically. We have the aircraft are clients, and those clients can attach to one or more subnetworks, again, during different phases of flight. The subnetworks connect the airplanes, and the internetwork connects the subnetworks. So we have native IPv6 routing within the subnetworks, using standard routing protocols like OSPF or what have you, and then tunneled IPv6 across the internetwork. Next chart. So in terms of the BGP details, each stub autonomous system border router is a stub autonomous system unto itself. All core autonomous system border routers are members of the same core autonomous system. The stub autonomous system border routers advertise their associated mobile network prefixes to the core autonomous system borders routing using eBGP. And in the reverse direction, the core autonomous system border routers originate default only, but they do not advertise any mobile network prefixes to the stub autonomous system border routers. And once again, I'm having pixelation problems with the charts. There we go, it's back again. The core autonomous system border routers discover all the mobile network prefixes in the system using iBGP, and they can connect the overlay to the global public internet in which case they would advertise only a short and unchanging aggregates like 2001 DB8::/32 instead of the dynamically changing more specifics, for example, /64s. Next chart. So then we have the need for route optimization. So hit space once, please. So initially, packets go from the source to the target by traveling through stub and core autonomous system border routers, which is a dogleg path. Space again, please. So the proxy for the source can send a neighbor solicitation message toward the destination to get a neighbor advertisement message back from the target. Hit space again, please. The target sends back a neighbor advertisement message. And next, please. And then future packets can go directly from the source proxy to the target proxy without involving any of the BGP routers. And now we have a route optimization. Next chart, please. So in terms of draft status, this is actually the second time we've been here at the Routing Working Group. We were also here for IETF 98. The draft has been presented at the ICAO Working Group I-Mobility Subgroup, and it's under active consideration there as a mobility solution candidate. And what we would like to do is identify an IETF working group to take this work forward. And that's why we're here at the Routing Working Group, to get some feedback from the community on that. So I'll take any questions.
So this is Chris Bowers. So just in terms of, just to kind of share with the working group, are you looking to standardize the architecture? Is there any protocol work, or is there protocol work that would need to be done?
So in terms of the BGP routing, that piece of it, I'm thinking would be informational, because standard BGP with no protocol work needed. The route optimization piece is some protocol work needed, but it's based on standards like IPv6 neighbor discovery. So I guess it's kind of a mixed answer. Some would be informational, other aspects of it would be potentially a protocol.
Okay, thanks.
AC Lindum, but as a co-author. But Fred, this document does not have those details in it. So this document is purely informational on how one would implement the ATN network using BGP.
That's correct.
Yes.
So it would be good, I guess, to, as we try to figure out what working group to put this in, understand like the full scope of the work moving forward, so that it can be, we understand what we would be getting into, or what the full scope is. So we'll discuss that with both AC and you and the other authors, and try to figure that out.
That sounds good. Thank you.
Thank you.
Okay.
Randy? It's me. Love the color.
My apologies for those people who have to see this again. They threw me out of the LSVR working group, so I went down the street to this bar. This was done in a white room. No, that doesn't have legal implications. It just means I was stupid. There is no IPR here. And this presentation is designed for BGP SPF at the top. A different north could be centralized, could be other topology mechanisms. For instance, Dr. Bugs, which he presented yesterday. So BGP-LS format, BGP SPF need link, neighbor, discovery, liveness, and addressing information. LLDP, unfortunately, is not only an IEEE protocol and complex, but it's got IPR above 1,500 bytes. And I'm overweight, and eventually this protocol will get a little overweight due to the fact that I believe we want to add some security to it. So the 1,500 byte limit's annoying. So still want something simple. So this is a new Ether type. And I'm just going to describe the Ether payloads, et cetera, not framing and dirtier details. This is dirty enough. Okay, the general topology is an east-west protocol. Does this work? Yes. Okay, at the Ether level, with AFI-SAFIs pushed down and Pardon? Okay. Sorry, Meet Echo boys. Okay, with Ether, left, right, AFI-SAFIs pushed down, and then northbound to, and this, as I warned in this example, BGP SPF. Okay, so this is the East-West protocol. It's essentially PDUs over Ethernet frames. The idea is to transfer inter-device link state. Okay, PDU can be multi-frame, and it has some glorp in it to allow that. Okay, and because SPF and the IGP payloads go over the same wires, we need to watch out for congestion. Okay, so the basic TLV is got the stuff for reassembly. Okay, and continuation. There's a checksum because of paranoia, length, and here are two basic types: hello, keep alive, and a capability exchange. There's checksum for the obvious reasons. Here's some suggestions that Russ Housley and Steve Bellovin threw at me, and in the draft you'll see the code. I know that I'm in the knock, as the Meet Echo boys are too, so we have a conspiracy. They know I walk. So anyway, the basic handshake, you get hello and liveness. Okay, are you there? You can negotiate timers. You can move AFI-SAFIs, V4s, V6s, and MPLS labels. Was somebody shouting at me? No. Okie doke. So you'll excuse me that this particular, as I said, was designed for BGP SPF, so the identities being exchanged are ASNs. The draft should be cleaned up and changed, so this itself is a TLV, so you can have other kinds of identities. Okay, a multi-point topology is just point to point, and you learn each other's MACs from the hellos, so we know each other, and we know each other's ASNs, and we can start doing high-speed keep alive, so you don't need BFD. And then we can negotiate some capabilities. Okay, we have requests, we agree, etc. What are the capabilities? Here's timer negotiation, for example. So you can tune the keep alive timers. You can say how many you're willing to miss, etc. Okay, and you also have a timer for the AFI-SAFI exchange. Okay, so now we know MACs, link state, ASNs. So now we can start talking AFI-SAFIs. There's a general frame for it. It's an AFI-SAFI capability. Yes, I'm willing to exchange them. And here are the ones I'm willing to exchange. And of course, this will be extendable. Now we know the AFI-SAFI of the neighbor, MPLS label, etc. So we can announce and withdraw them, of course. It's over an unreliable transport, so there have to be sequence numbers and ACKs to provide some reliability. So there's a wonderful sequence number. There's an ACK. So here's an IPv4 announcement, sequence number. number, AFI, SAFI, and as many V4 prefixes as you want. Each one can be announced or withdrawn or marked as, hey, by the way, this is the primary on my interface. Okay, V6, surprisingly enough, 96 more bits, no magic.
So these prefixes are just for the interfaces? They're not?
Right, I'm not
Okay, I
exchanging
just wanted to
routing
make
tables.
sure that you still
I'm not
have
exchanging routing
BGP
tables.
doing that.
Going to push up to SPF or whatever's above for all that. Right, just the interfaces. Okay, MPLS, it's not very exciting. You can use multiple labels to allow one label to be associated with multiple V4, V6, blah, blah, blah. Okay, so you've got labels, you've got liveness, you've got some AFI-SAFIs. What do you do with them? Push them north. Okay, so at the Ethernet layer, we don't want to do topology discovery, et cetera, et cetera. So it goes to BGP, in this example, SPF, going up to the Dijkstra layer. I don't go all the way up because you might want something other than RFC 7752, the BGP LS shim.
Hi, Rick Taylor. Didn't mean to interrupt in the middle. Talking about the information you're pushing across.
It's not routing information, it's interface addressing.
I understand. Trust me, I've worked on very similar protocols and everyone keeps asking me about the routing. But no, the link information. Do you want to push up any sort of metrics about that link coming off the PDUs? As well as just address, you know, my duplex information, that kind of stuff could be useful going up.
Point. Okay. So BGPLS specifies in 7752 format for how to feed this to SPF. Okay. So how do we shove it upstairs? You're within the device. Notice each one of these is within the device. So we can be optimistic and hope that there's a reliable intra-device transport. So no ACKs, no sequence numbers, et cetera, et cetera. We assume a nice fat PDU and we can cram a lot into it. Okay, so we shove everything we know about our neighbors up north, and we can do incremental updates. So 7752 shim says, tell me what you know. The link layer says, hey, here's a piece of transfer, here's a continuation, et cetera, et cetera. Here's the count of links, et cetera. Again, the ASN is the identifier. May want to change this, have it be a separate TLV. Okay, so routing is done in the upper layers. BGP SPF is the one that this presentation is targeting towards. Okay, so those will talk between the devices and discover the topology, provide routing, and Bob's your uncle.
So I had a question, Chris Bowers, about is there an assumption about point-to-point links here, or is this expected to work for point-to-multi-point?
As I said somewhere back in slide 42, multi-point is presumed to be multiple point-to-points. His model is multiple point-to-points.
Okay, so it can handle broadcast interfaces, but doesn't try to do anything
Nothing
special. Okay.
Hello, this is Maysel Nadai from University of Essex. I just wonder in here, how is that different from SPF link state discovery? Sorry. How is the protocol you're presenting is different from OSPF link state discovery? Sorry if it's a silly question, but I just failed to see the difference.
Actually, I am not an OSPF expert. I'm an ISIS addict. But no multicast, for instance.
You cannot do multicast with
Let
OSPF.
let
Sorry.
AC.
AC Linux Cisco system. This is a discovery protocol.
Right.
Now,
No routing.
Yeah, no routing, no installation.
But you said, why is it different from OSPF discovery?
Hellos. Somebody actually went to the mic in LSVR and suggested taking the hellos out of either OSPF and ISIs, and just taking that part. And there have been, going back to the early 2000s, I remember, I think it was people at Stanford and in Manet, they have decomposed routing protocols into, different, three
Frameworks that have the different layers.
Yeah,
pieces
yeah,
of the
yeah,
routing, discovery, et cetera, et cetera.
and flooding.
Yes.
Yeah, the three pieces and doing them separate and plugging and play different ones. So there's many ways to solve this problem.
Rick Taylor again. I really like this work. It's very similar to some work we've just completed in Manet, but instead of discovery on Ethernet, it's discovery across radio systems, but it's the same problem. And just to reiterate, including some metrics in there is really useful, because although, the BGP might not be using it at the moment, one day we can start to get all this traffic engineering stuff tied together. And this goes back to the early presentation in this, it's all about intent. The more information you can get up from the bottom layer at source, the better.
Point taken.
Yep.
For the other example for the top isn't BGP, by the way. Another example is Jupiter Rising, where the control centralized so that it can use very much. So thank you. Kayur, who are you?
Kayur, just to say more on AC's point, one should think of this protocol pretty much like as how BFD is, to provide a generic link level liveness to all the protocols that can exploit once you have the liveness detection. This is something similar from a discovery standpoint.
He should confess that he's co-author.
Question. You've mentioned label distribution in one of your slides. Correct?
Was that an accusation?
Merely a question.
Yes. That's pushing it up. Capabilities. Oh no, too far.
Why would you do so?
Pardon?
Why would you do so? I mean, if control plane exchange, traffic will go unlabeled anyway.
Because I want to know what label you can handle.
You mean the block of labels? Or
I mean, what's the meaning of, so a single label, we don't understand the use case for this. Like typically you would send, multiple labels received by a given router would have different forwarding implications, right? So what is...
And you can pass multiple labels.
Okay, then it starts to look more like you're doing routing in this, which we'd like to better understand.
Not intended. I'm just saying these are the labels you handle with what AFI-SAFI.
Label blocks, what's the meaning?
Yeah, what does it mean? The router advertising this, what does it mean when it advertises a given label for a given prefix?
Kayur Patel, again, it's a simple binding that says a prefix has, on a interface, has this label value semantics. It could be probably used from a layer 3 server to just announce it to the first hop router, or it could be used from a router for its locally configured interfaces. It's not meant to announce an overlay interface information.
There's nothing deep here.
And it's just one point, hop by hop. It's not meant to take that information and send it over other link from this protocol's perspective. That would be a job of routing protocol.
The use case is still unclear, but we can discuss it offline. If you meant to use it as a liability protocol, I would advise to use a flag similar to P flag in BFD, where you start flow slow, and after you've resolved each other, you could go faster than 1 second or so.
Sure.
Thank you.
Okay, next we have Dirk Trossen talking about service routing over path-based forwarding.
Thank you. So thanks for accommodating us, and I think about a day before. A bit of background for the slides. We organized the BARBOF on Monday evening, and one of the outcomes of the BARBOF was the suggestion that Alia made for maybe presenting the thoughts here at the routing working group to say, what is it, where could be a potential place, what are the potential work items to work on, and if the story, in a way makes sense. Right. So the BARF was on Monday evening at 5:40. So the starting point that we have in this work is to start from existing PCT-based approaches that utilize what we call a path-based forwarding, things like BRTE, for instance, or two of the references we make in drafts in the SRC working group is SDN with bitfield-based wildcard matching, which allows you to describe encode a path through the network and then have relatively simple constant state switching, or SDN with flow aggregation, which is a different approach of doing that. The architecture is very similar. We try to abstract this with a slide with a figure on the right. We have some sort of ingress. We have a control plane communication to the PCE for the path determination, and then it walks. It's sent across the network between the forwarders to the egress on the right-hand side. The possible benefits, and I'll come back to those later because some of them have been demonstrated in realizations, is what we call ad hoc multicast, which is the creation of multicast relations at the ingress based on existing path information, potential path, direct path mobility, repointing path relatively quickly, and therefore, no anchor points in the network. Predictive mobility, we saw a presentation on Monday in the BARBOF on predictive mobility, where information is disseminated towards handover candidates. It's flickering quite funny. It stopped. The edge resource management that can utilize things like network coding for multi-source, multicast. We saw a presentation on this on Monday as well, but where the resource management is done between the ingress and the egress. Or a fast redirection of upper layer protocols through path repointing. These redirection scenarios come from some of the ongoing 5G work for data center-based control plane in 5G networks, for instance. There's some existing work. The only one I list here is stuff that we have in the SRC working group. We have an applicability use case in BEER itself, which is called HTTP multicast. Sorry, a question over there?
Mm-hmm.
Yeah. Go ahead.
Thank you. Greg Mirsky, ZT. What is the roles of PCE if you plan to use BRTE?
The path calculation.
Path calculation in PCE?
Yeah.
But if you use PCE for path calculation, why not to calculate, for example, segment routes and then use BEER without BRTE? Because BRTE gives you path control, so you don't need then calculation of the path. You can create traffic engineering underlay and then use BEER on top.
That's actually how they. So we use the BRTE here as a reference.
So it could be different scenarios, either PCE with traffic engineered underlay and BEER, or BRTE.
That's correct. Actually, in the applicability use case, that's based on what I say, normal BEER.
Thank you.
That's correct. Sorry, I should have listed that one as well. That's correct. So the problem that we addressed in the BARBOF on Monday was how to realize what we call service request routing on top of those technologies that provide quantitative and qualitative benefits from doing so. The definition of the word service here is relatively wide, and starts from relatively high level layer 7 technology, the HTTP and CoAP, down to IP multicast and IP unicast. And we apply the benefits across a number of these services if you take that very wide definition. And I'll come back to this in the layer slide on the next slide. We also would like to identify the architecture components, and this is why we came to this working group to present this, that would potentially require standardization if you think that way. So the nodes and the layers of the various messages, and these obviously are relatively high level there, not all of those on there, that we see is, so again, you recognize in the middle is the same ingress egress PC, and let's leave the, even if you were using normal beer without PC in the middle. And we introduce on either side, we have the actual endpoints or peering networks on the far left and the far right. And in between the ingress and the endpoint is what we call the service router, which applies different service mappings either on L7, on L4, and L3, and puts this into a message format which we abstracted. They are slightly different, obviously, per service, but abstracted at the very bottom, where we utilize a path identifier, which could be either in the SDN case, we are reutilizing because of SDN matching field limitations. We utilize IPv6 source destination addresses for the path identifier. BIA has its representation of path identifiers. A hash of the service identifier and the potential return identifier for protocols and for services like HTTP, a request identifier, and as well as the actual service fragment, which is the actual payload itself, either encrypted or decrypted, depending. The example deployments that we see, and this is one example how this is currently being deployed as a monolithic solution, is over an infrastructure as a service provider, which is in green with the typical type of technologies. Like, one of the deployments we have is based on OpenStack and using Floodlight for the SDN controller interaction at the very bottom. And the red bit, which are the service routers, is the so-called edge cloud provider. This is a mobile edge computing scenario, which is an NFV provided software solution at the edge of the network. And then again, on the left and the right-hand side are the application or service providers. One of these deployments is done in an EU-funded project, which deploys in Bristol as well as in Barcelona. It's a fully orchestrated platform that utilizes Etsy manual orchestration to deploy the software in a pristine municipal scale infrastructure. And these are a couple of SDN switches and a number of micro data centers in the city. It takes a couple of minutes to deploy over a pristine OpenStack infrastructure. It uses SDN based on at the moment, we do not have any availability of peer components, which is why we're using SDN. OpenStack for compute, and it utilizes the benefit of the service routing approach that are shown in 2 slides down. It's deployed in Bristol, Barcelona, as mentioned, with trials planned throughout the year. So this thing, it kind of works, but what we came here for is to see, okay, if we take some of these things apart, what need for standardization would we potentially see? And so let me go back to the slide before. So the needs for interoperation. So all of this at the moment is one monolithic software solution. If you took this apart into the actual SR, so one SR interoperating with another SR from a different vendor, we would see interoperation needs for the general message format, for the applicability for specific services, for HTTP, IP multicast, core. These have different service framings. The path ID mapping onto the particular technology, we know how this would look in BIA, we know how this would look in SDN Bitfield, but there are differences. Another interesting one at the moment is how this would look in P4. It makes it significantly simpler.
What are your expectations with regards to control plane?
This comes in the second one. So I started with taking the SRs apart, right? And so there are particular things in the exchange between the SRs and the data plane that we'd see a need for standardization. On the control plane is the SRPC protocol to map the actual service identifiers on the path ID, working on a Yang model for the resolution and the path update. There's also an aspect in particular for the rerouting capability to update path at runtime, and therefore that needs handling from the control plane side, and obviously the resolution request and the path updates.
Just for clarity, when you use SR, you are not talking about segment routing. You're talking about service router.
Service router, yes. I used to have the acronyms on the first slide, so they've gone lost during the other slides.
Some people are rather sensitive to this acronym.
Sorry. We changed the acronym in the interaction with the IETF 3 times because we always found a toe to step on. And I think that's the case every time you go somewhere. The other aspect we see in the resource management. So how does the error and flow control look? If you talk about reliable services like HTTP, for instance, how is the end-to-edge mapping being done? How's the flow setup and the security mechanism being handled? So these are all things to agree upon if you take the SRs apart and interoperate between different SRs. What are benefits that actually would demonstrate? I wanted to highlight those because they're different things that depend. They're different use cases. There were different trials, different use cases. They are not obviously all in one. We demonstrated the edge resource management, which allows for optimized resource management by still being TCP friendly. There are some benefits from the edge-to-edge resource management when it comes to cheating at the endpoint, which means establishment of hundreds of TCP connections, for instance. We also work on network coding and multi-source retrieval solutions, which have direct benefits in terms of latency and utilization of the network. The multicast for HTTP response delivery, which is the applicability use case in BEER, has been demonstrated in a number of demos. So the scenarios here are video delivery, database synchronization, software downloads, anything that is somewhat kind of like time synchronized, and it can be kind of like time synchronized because the multicast relations per response are ad hoc. So therefore, if there's a slight out of sync, you just get unicast, right? And we demonstrated this several times. The typical video scenarios, either statistical multiplexing over a large catalog. Somebody is always watching more than one person is watching a popular video. Other use cases we demonstrated are VR, virtual reality, augmented reality in spatial concurrent scenarios, which means you're looking at the same thing with a VR headset. Therefore, you have the same content you're pulling from the server for the event that's happening. There's also, by the way, reflect in server load reduction. So the same way, if you do HTTP request suppression, the same gain you're getting on the multicast, you're actually getting as a server load suppression. And for services like MPEG Dash, you can suppress requests because they're stateless. Fast service request routing, there's a use case that comes out of 3GPP. In the latest release 15, 3GPP proposed to move towards a service-based architecture, finally using HTTP for calling control plane services. And we can use this to very quickly reroute load balance to other data centers for service requests, control plane requests. Direct path mobility, I set the presentation on Monday from Essex University on repointing the path. Not only direct path mobility, but also predictive mobility, which means you use network coding to actually have several splice the path up into paths to the candidates, and then use network coding to diffuse the content. You can do things like seamless HTTP session transfer. If you switch from one service router to another one, the session is automatically continued, and therefore you don't lose what you've already partially downloaded. We've demonstrated secure content aggregation without triangular routing, because it removes the region server in the initial request. The southbound integration, that's something for those of you who are interested in the SDN integration. I can explain that separately. The cute thing is it's a flow-independent state, and therefore the TCAM requirement is constant with respect to the number of output ports. That's quite neat, and we can do relatively easy quality of service support. There are a number of demonstrations there. So the next steps, and again, this is why it was suggested we come here, is to get feedback from the routing group on the motivation. Does it sound? Is there a need for interoperability? Does the proposition make sense in itself? What are the various activities that would require standardization? The ones we presented around these three areas. But most importantly, the place of work for this. What would be the right group to put this in? We do have, we established identified relations that we presented also on Monday very briefly, and we continue also with the existing ones, most notably with the SFC working group, the BEER working group. There are discussions ongoing, and maybe others we would potentially identify as an outcome of today. And we will obviously continue the implementation efforts. Good. Any questions, comments?
AC Lindum. I think you need to, do you have a document? This was added late, right? This one?
Yes.
Okay. It seems like what is different here than routing to an ACAS address for services and all the variations of that. You know, what more is this than that?
Okay.
Okay.
So if work is to happen in ATF, it would be scattered across different working groups. So beer extensions and applicability obviously should go to beer. You would need PC extensions, which don't exist today. So it would belong in PC. Way you map the naming entries to bit strings should be defined as well. So significant amount of work and very interesting work. Thank you.
Mm-hmm. Yeah, thanks. Yeah, I think there were discussions after the beer. I couldn't be at the beer meeting yesterday, but my colleagues were because of other commitments. I think they're discussing around the applicability use case.
They only presented HTTP beer.
Pardon?
They only present HTTP beer.
Yeah. Okay. Thank you.
Please do continue working. It's really interesting.
Okay, thanks.
Okay, well, thanks a lot. That closes out today's session, and we look forward to following up on a lot of issues we were discussing. I believe the blue sheets are, if you haven't signed the blue sheets, please hunt them out. They're probably near the back, and sign them so we can continue to get a reasonably large room. That would be good.
With air in it.
Yes. Yeah. And we look forward to seeing you in Montreal if you can make that, but certainly participate over the list.